Okay, greeting computer nerds. Let's continue on here. We've got a couple short topics that we're gonna kind of combine together because they're similar, and these all have to deal with integer data types and some operations that happen on them, some weird things that can occur under some extreme scenarios. So first, I want to talk about integer division. Okay, and one of the reasons we want to reiterate this and really focus on this topic is the fact that it's a big source of problems that occur and bugs that occur commonly, especially when people are new to the topic. Okay, so especially because some of this is a little bit counterintuitive. So let's think about what happens when we're dividing two integers here. Okay, and we want to remember when we're dividing two integers. Okay, if we're dividing two integers, the result is an integer. Okay, which means we're losing everything to the right of the decimal point. Okay, so when we look at this and we say we take 13, integer 13, we divide it by 3, okay, we're only, the end result of that, okay, is going to be 4, right? It is not going to be 4.33, okay? We lose everything to the right of the decimal point in a process referred to as truncation. We truncate it. Different than rounding. Rounding would be that we're gonna bring it to the closest integer. We're not doing that. We just throw everything away. Okay, and that's illustrated most clearly here when we look at b. Okay, if we did the math, obviously that would be 0.9. Okay, but we're truncating everything to the right of the decimal point. The end result of that is actually 0. 0 is what's stored. Okay, because we're taking an integer and dividing it by another integer. Okay, same thing down here. We look at this, right? I know the end result of this entire expression here is going to be 0 because when we have integer 1 divided by integer 3, right, that is going to get truncated down to 0, and then we're multiplying by 0, so the end result of that is also going to be 0. Okay, and then when we look at these two variables here, integer x divided by integer y, 10 divided by 4, right? The result of that is going to be 2, right? Truncating everything to the right of the decimal point. Okay. Now, keep in mind, we did see a little bit of this earlier on. If we have something like this, or we have a type double, right? Which could either be that the variable was declared as a double, or we have something like 0.0 or point something in which that is being interpreted as a double, a type double. Okay, now it's different because we're taking an integer and dividing it by a double. The end result of that actually is a double. It's not an integer. So in this case, we're actually preserving the information. Okay, so in this case, when we have 10 divided by 4, we are going to preserve that information. Okay, so that's one of the reasons why being cognizant of the data types that you're using and how things are being stored is very important, okay, to avoid weird things coming up. Okay, now I want to hit a couple points in this video. We're going to kind of tie them together. Another one is a common operator, okay, operator that we use with integers, and this is involving the %sign, the modulo operator. Okay, the modulo operator designated in the C language as well as other languages with the %sign takes the remainder of what's left after a division occurs. Okay, so if we said that we had 23 divided by 10, right? Well, we have a remainder of 3. That's going to be the result. Okay, this tends to be something that is very useful for a variety of applications in our programming logic. Now, the end result of the modulus operation is always going to be in a particular range, right? And that range is dependent on what we're modding by. For instance, here 10, right? The remainder is going to be restricted in the range, okay, of 0 to 9, right? You can't have a remainder outside of that range for kind of obvious reasons, right? So that's kind of an important kind of caveat. And that's one of the things that makes it useful for a wide variety of applications. And we'll see it. We'll apply it in practice in the context of real problems later on in the course. So here, let's look at a couple of real examples. If we're taking 50 mod 2, well, 50's even, right? So one way that we can use this is determine odd or even numbers. 50 mod 2, right? The result of that is going to be 0, right? Which actually indicates that it's that 50 is indeed an even number. So we can actually check if numbers are odd or even. It would be one application for this. Likewise, we would take 51 mod 2. All right, 51 divided by 2 is going to have 1 as a remainder. Right, so the result of that is 1. Okay, 78 mod 10, right? We're going to 78 divided by 10 is going to have 8 left over as a remainder. And that's really all there is to it for looking at the mod operator. Okay. Now, one more thing that I want to show you in the context of integers is what happens when we go beyond the range, beyond the supported range of our data type. In particular, we're going to look at integers. Okay. Now, we've looked at prior, right? We saw in a prior video that if we had particularly an unsigned integer, okay, if we had an unsigned integer, the range of values that can be supported is from 0 to 2 to the n minus 1, where n equals the number of bits. Okay, so we saw that 2 to the n minus 1 is going to be our largest integer that we can store, assuming it's unsigned. Okay. Now, well, what happens if we go beyond that range? Okay, what happens if we go beyond that range? And I'm gonna this is something that occurs, is called integer overflow. So I'm going to do a simple example with a very small number of bits just to kind of illustrate this point, right? Let's imagine that we had that n was just 3 bits. Okay. Well, we know then that the smallest number is going to be 0, and we're assuming again unsigned, right? Unsigned, so it's all going to be positive. And the largest, okay, is going to be 7, 111 in binary, okay? Well, what happens if we add 1 to that, right? Well, if we add 1 to this, right, in binary, what's going to occur is we're going to get, this is the result, right? That's 8 in binary. However, if we're only able to store things in 3 bits, which would be a really weird way of storing things, we don't really do that in real life. We store it by bytes, which is 8 bits, but for the sake of this example, well, if we only have 3 bits, right, the effective result that we're storing is 0. We're storing 0. Okay, so this has this weird thing occurred where we added to a number and it actually went from 7 to 0. It actually went down. Right, that is what's called integer overflow, right? Where we went beyond the maximum range and it like reset. It's almost like your car odometer, right? If you imagine that you hit, 1 million miles, it would actually, if it didn't have that digit there, it would reset back to 0, right? So that's it's a problem that occurs, and that's one of the reasons it needs, for certain contexts, if you have the ability of going up to too high of a number, you have to be cognizant of what could happen and how you should be storing the information. All right, let me show you an example. I'm gonna pull up something in a moment, and I'm gonna declare a number as a short int. Now, a short int has the number of bits that are stored there. The number of bits is actually 16. Okay, so 16 bits. Okay, so that's going to give us the maximum range if we did it unsigned as 2 to the 16th minus 1, which turns out to be 65,535. If we did that math out, that would be the largest number that could be stored for a short integer. So what happens if we go beyond that? Let me show you that this is actually something real, right? Here I've got some code. I'm declaring an unsigned short integer, and I'm declaring it initially as 65,534, right? I'm printing it out, adding 1, printing it out, adding 1, printing it out, adding 1, printing out, adding 1. Okay, and we'll see when we run this, what occurs here is that we hit the max range here. Right now, when I add 1, it goes back down to 0 and it resets, just like an odometer resetting back around to 0. You ran out of the space that we can store with it. We ran out of the number of bits, and it went back down to 0. Okay. Okay. So that wraps up some of these integer operations and integer nuances that we want to be familiar with to kind of being able to use that data type under a wide variety of situations. Just to kind of recap what we talked about in this video, we looked at integer division. We looked at integer division and being mindful of the fact that it truncates, basically in a sense round down to the lowest integer. So you need to be mindful of that is occurring when you're dividing by two integers, and make sure that's what you actually want to have happen. Okay, we looked at the modulus operator, and we looked at how that is the remainder of it's the division. It takes the remainder, and that's what's stored. All right, it tends to be very helpful. We'll look at why later on in the context of real problems. And then lastly, we looked at integer overflow. What happens when you go beyond the maximum range of an integer and how it resets back around. By the way, the same idea works if you subtract and you go beyond the lowest range. It's something called integer underflow, but it's the same basic idea. You wrap back around. Okay. All right. And so that'll wrap up our discussion with integer data types, and we'll be able to just use them to solve problems later on.